Okay, so 6.
It is.
A sample of size n equals 4 is taken from a normally distributed 2011 cells data. What is the probability that the observed X bar is less than 40? So this, we have to do a little math problem. So I tried doing it with the 60, 68, the 95, and the 99.7.
Mm-hmm.
Is that how you guys did this one? Am I on the right track?
Yes.
Yeah, you're on the right track.
Or what's the best way to do this one? Is it use the applet?
Well, no, we're going to want to find the z-score. So, yeah, actually, you could use the applet, but it would be at the end.
Okay.
Hang on. I had my first. No.
Okay.
I can barely hear you.
Yep.
Can you hear her very well?
If you have, do you have any of these then? Yes. Where are they? I can get them for you.
You guys go with it.
Well, you were explaining.
I only wanted to hear what she had to say because I thought that it would help me.
Yes. Well, I think so also. So if we give her a minute, I think she'll be back.
Okay.
It was a little more difficult than that. That was a longer trailer. And I did a 2-act one. It was shorter. It seems to be a little bit easier.
Well, so what's the easiest way to do this one then?
I'm not sure. That's kind of why I'm hoping Leah can get back and explain.
Yeah.
No, you don't. Bye. Let's talk. Let us talk. Go. It's like a peanut butter. Elisa, what is this?
I don't know. It's called like peanut butter beef stir fry.
It's what?
I think it's just called peanut butter beef stir fry. I like peanut butter, soy sauce, and chili.
Peanut butter beef stir fry.
That your sriracha sauce in it.
Oh, really?
Sorry. You wanted to know what he's eating.
Well, that's, yeah, I think he needs to. It dumps in. I'm sorry. I don't know. You've got something wrong in there. Maybe you can switch it to your other one then. Is your mic on? Okay, so what she's done is she took 40 minus the 45,
Mm-hmm.
and then divided that by the 10, by the square root of 4. which equaled the -1.
So you said she
you
divided that by
can you
10
show
and
that?
then square root of 4.
Yes.
Yes.
Can you share your screen?
Yes. Okay, we're going on to our summary.
Sorry, I'm asking you to do a lot.
So I need to do something.
It just helps me to see.
And I emailed this to try and help. Okay. Can you see number 6 now?
Okay. Yep, I see that.
So how did you do that? Or where did you get this from?
I got that by just working through it.
Hang on 1 second. You need to click down on it.
Okay, so take 40 minus 45. Alyssa, can you see
Yeah.
that very well? So 40 minus 45, divide 10. And then the
So-
square root of 4 equals a -1.
So if you go 40 subtract 45, and then that's what, -5, and I put that to the side. And then I do 10 divided by
Talk louder, I guess. I don't know.
And then that, so you need like two different numbers. So then the 10 with the square root of 4 divided, and then divide that by that -5, and that give you the -1.
So let's see here. So I had a -5, and then I divide that. Hold on.
And then let me share my screen.
Square root.
And that's what I have on my probability applet after I put. And that would match up to what she says. Which is about
Okay,
60%.
so
Are you guys waiting for me?
no, they're waiting on me.
I have my headphones out. Can you still see the screen?
We were talking and most of it.
So in the area on the applet, you're gonna put a 4.
Yeah. You still see my screen? I have to screen.
Your screen is black, Alyssa.
Okay, let me go back and see. Wonder why.
Anyway,
That's a close
See you
out of it.
now.
Because I have my applet up. Let me see if it'll work again. Oops. There you go.
Vice President Andrew?
Okay, so
Is it? Do you see the applet on my screen now?
I do.
Yes.
Are you guys waiting on me still?
No.
Sorry.
Oh, we're not. Are you good, Stephen?
So the area is 0.317. Do
No.
I have that right?
0.1587.
Okay, so I gotta unclick the blue on the right side.
Yeah.
Okay. 0.158. Yes, I got it.
Okay.
Okay, so you want me to take on number 7?
That'd be good.
Okay, a sample size n equals 4 is taken from the normally distributed 2011 cells data. What is the probability that the observed x bar is greater than 35 and less than 55? So if we plug in that sheet, kind of the one that Leah had showed us,
Yeah.
so we'd have the mean minus the 55. Are you up there, Leah?
Take the 55 minus the 45 and divide that by 10 and square root of 4.
Really?
-2, and you put your -2 into that. And then the other one is the 55 minus
She wasn't happy.
+2. So you have to do the blue in the area in between those.
What happened? As a driver?
Right, so your area would be 0.9545. Did you guys follow that?
Yeah.
Okay.
Do you know what I'm keeping up on? So he wasn't doing as good as job as he.
Okay.
Can I see your screen one more time, just to make sure that I'm doing it right, Leah? I think that's what I have too, but
I like Dana.
So let's back up. So I
Oh,
plugged in at 35 minus 55,
you never had any problems with any of this?
but
Do it by your, you need to do that by the mean, which was the 45. So you do the
where did you get
45
the?
minus the 55. It's still off of the 2011 data that is
Oh, okay,
above on the top.
that makes sense.
Okay.
Can you see the screen, Alyssa?
You see how he's loading the chair?
I can see it, Leah. Yeah, so you're there. Or, yeah, I just. Yeah, I just clicked on your name, so I guess I've learned something new here. All of our pictures down at the bottom, if you click on them, that will stay on the screen.
yeah.
Yeah, I didn't know that.
That's
Oh, sorry.
what I've been doing, like if you guys are showing the screen part.
Yeah, that's why I kept asking, okay, talk, because usually when somebody would talk, it would pop up on my screen. Oh, jeez. There's a dumb moment. That's a senior moment for me.
Hey, at least you understand the problems.
Oh,
It's okay.
barely.
I just realized that the 41 and the 49 are both 4 away from 45. And, yeah, 3
Yeah.
minutes. I guess I kept staring at it, thinking, "Why is it the same?" And then I realized what was happening.
Hey, Alyssa, on your normal probability applet that
Yeah.
you've got up on your screen right now,
Yep.
what is this one for?
This one's for the one that we're on right now. I just haven't
Number
clicked.
7? Oh, okay. You just haven't clicked the Z-score off to the left?
Yeah.
Okay.
I think that's it right there, right?
Yep, there we go, and there's the right answer.
Yep.
See, I did it. Where's the right answer? Oh, so help me know when I'm supposed to click what area.
So if it's saying it wants it in the middle like it is right now in between the two, you want the sides cut off, but if it's saying if it wants more than such a number, then you're going to only have like the right side clicked. If it wants like less than such a number, it'll just be at the left side.
So where it says greater than 35 and less than 55, that's when I know that would be in the middle. That's
Yeah.
the section that I'm looking for.
Yeah.
Got it.
Yeah.
Okay. So the answer is 0.9545.
Yep.
Okay. All right. You want me to do the next one?
Sure.
A sample of size n equals 25 is taken from the normally distributed 2011 data cell, or cells data. What is the probability that x bar is greater than 41 and less than 49?
I still have my screen up.
Okay. That will help.
So that's kind of done the same, except for it'll be the square root of 25, correct?
Yeah.
Okay. At least the square root of 25 is easy. My daughter bit all the buttons off my calculator yesterday.
Oh, nice.
She was sitting in a corner. I kept seeing these little rubber buttons all over, and she's sitting in the corner at the calculator chewing them off. Oh my goodness.
Mad at mom.
Yeah.
So this one, plugging it in, it comes up to the same, those z-scores of -2 and a 2.
Well, the z-score is 2.5 this time instead of 2. I think. Or, no, sorry. I'm looking at your number 9.
Oh. Yeah, I thought we were still on 8.
We are still on 8. I was just looking through numbers.
Yeah, but I think it's the same answer as number 7 because it's a -2 and a 2 for the probabilities. And
It
has to
easily
be
could be because they're just taking a larger sample size.
Right. Right.
So.
And so between, it has to be greater than 41 and less than 49, so it's still that middle section on that applet.
Yeah.
So it's 9545.
Yeah.
Okay.
So I got lost. So I do the 41 minus 45. And I get -4. Is that correct? Divide 10. I get a -0.04. And then I square that, correct?
Right.
And I am getting a 0.16.
Square root of 25.
Square root of 25.
Square root of 25 is 5, and so it would be 10 divided by 5, which would be 2, right? So that would be 4 divided by 2, which is 2. Because you get 4 from the top number and then the 2 on the bottom.
Right, which would actually be -2.
Well, yeah. Because you'll want to
we're
divide
following
the 10 and the square root of 25 before you divide it from the top part.
Right.
So how did you get a -2 out of all that?
Because it doesn't really matter because it's going to be the same either way.
Because I got a 4 now after I did the square root of 25.
Well, it's negative because it should have been, I think it's technically, it'd be 45 subtract 50. And so that would give you the negative on top. If you do it, because I think if, because it's a value, subtract the mean. And the mean is, no, the mean's 45, right?
Yes.
So yeah, that'll be right.
So the answer to this is 0.9545 as well?
Yes.
Yep.
Because you have a -2 and a 2. So it's the
Oh, okay.
same on the applet that we did on the last one.
Okay.
So did you follow that though, Steve? Are you okay with those?
I did. It just takes me a while.
It takes me a long
that's good.
time too. It's alright.
Does my paper help?
Yeah, it does.
Okay.
So did you type all that in?
Yes.
I'm
So the part
impressed.
that's highlighted, she did.
Right.
Way to go.
Okay, I thought it would help.
It's very helpful.
It is helpful.
Steven. I did
What did
email
you
it to
say? You'll
I
email
emailed
it? Oh, you did?
Yeah, she already did.
Wow. Speedy.
Helpful.
Yes. So now number 9.
Uh-huh.
Do you want me to read it? A sample of n equals 25, which is taken from the normally distributed 2011 cells data, which is the probability that the observed x bar is greater than 50.
Okay. So that would be, I guess I should put 50 divided by 45. That's 2.5. Okay.
Right, so the 2.5, and then
And
putting
then
it on the right side. So we end up with, what, 6% or 0.0062?
And then we just, oops,
So
0,
is
0,
that
6, because I think, oops. So is that it?
Yeah, did I do that right? On the right side? Yeah, 0.0062.
Yep.
Okay. Okay, number 10. This is when we start getting new data. So, air computing sold an average of 40 units, P phones per minute in 2010 with a standard deviation of 12. And they looked at their P phone sales data and determined that the distribution is right skewed. Number 10, samples of size n equals 4 are taken from the right skewed 2010 P phone sales data. What is the shape of the distribution? Of course, it is right skewed. I like those kinds of questions.
They're all that easy, right?
Yeah, I wish. Okay, so samples of size n equals 40 are taken from the right skewed 2010 P phone
Would that
sales
be
data.
normal?
Yes, it would because of the 40, the size of 40. Okay, and is there a theorem that justifies your answer to question 11? What is the name of the theorem? Central limit theorem.
Mm-hmm.
That's the one where it says that if
Do
it's
agree.
normal, then it stays normal, and but if it's a larger sample, then it goes normal,
Yeah.
right? Okay.
Yes.
Okay, number 13, a sample of size n equals 4 is taken from the right skewed 2010 P phone sales data, and you want to know the probability that the observed x bar is less than 35. Can you compute this probability using the normal probability applet with the information you have?
I don't think so.
No.
Oh, okay, yeah, and your thing's saying no, because it's right skewed.
Yep.
Yeah, that makes sense. Okay. Okay, number 14. A sample of size n equals 36 is taken from the right skewed 2010 P phone sales data. What is the probability that the observed x bar is greater than 36.5? Okay.
We
got
still
the
find the
answer.
z-score and things just the same way as
Yeah, I think
normal,
all these
right?
questions are primarily really off the same
Yeah,
spreadsheet, the same calculation.
I think it is as well.
So Leah, scroll down and I'll read it right off of there and make sure that we're all good. Oh, there you go. Yeah, you are now. We can see it. Okay, so she took 36.5 minus the 40.
Mm-hmm.
It fell back up, Leah. Yeah, it's okay. And then divided that by 12, which was the standard deviation, right? Yes.
Okay.
And then square rooted it to the 36, which gave her
Which is 6.
negative 1.75. Then if we put negative 1.75, blue on the right side, because it's right skewed, right, Leah? Greater than. Okay. Yes, those throw me off. Those confuse me. So the area would be 0.9559 or
That's what I got.
96%.
Okay.
All right, we still
That's
all
what I
good?
got as well.
Okay. All right, number 15. A sample size of n equals 36 is taken from the right skewed 2010 pphone cells data. What is the probability that the observed X bar is between 37.5 and 42.5? So those two are in the middle, right? What do you got there, Leah? You did so wonderful, Leah. I gotta hand it to you there. Well, yeah, exactly. We'll fix that later. Okay, so we took 37.5 minus the 45 and divided it by 10.
Minus root of 36.
Okay, why did we divide it by 10?
10 or 12, it should be 12.
Yeah, okay. Oh, very good. Okay, so that should be 12. Okay,
Okay.
divided by the square root of 36. Oh, look at you go, Leah. Yeah. Okay, and then, which gave us what, negative 1.25? And really, since those are both in the middle of that, then we can just plug in our 1.25.
Yeah.
And we would put it in the middle. Is that what you got, Leah? The blue on the right side, or between the two areas. Okay, I'm not following that yet.
Yeah. It's because
Between.
the first one, it's on the right side of the first one and the left side of the other.
Well,
Okay.
don't you add up those two numbers and then subtract it from one, and that gives you the answer?
Yeah, you can do that too. Yeah. Very good. Okay, so is everybody good?
Mm-hmm.
Done.
Yeah, we think.
Now we have to try the quiz, right?
Yep. We're braving it. Okay. Meeting. I'll try and pull up the group meeting instead of the homework. Yeah.
You left lesson 7?
Yep.
Yep.
Hey.
Did
I
she
just don't want
complete
to
that
pull it up
reset
wrong.
last time?
Yeah, she did.
Okay.
Okay, so number 3, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z negative 1.358.
So you're taking the two outside blue ones.
Okay,
So those
and
are
then
the
put
outside,
in 1.358, right?
Mhm.
So is that what it's trying to find, is finding the area on this, right?
And it's the outside parts.
The two outside
Diane?
parts, I think.
Okay, so it look.
So then we'd have 0.1745.
Is that what your guys are getting?
Yeah.
I didn't see. Sorry.
Click on all this page.
Okay.
Sorry, guys. I went to the homework and not group meeting.
Oh no.
Oh, it's one of us every week.
All right.
And then we have to round it to 3, correct?
Yeah.
So,
So 0.175.
okay.
All right, number 4. Are you with us, Stephen?
I am now. What was
Okay.
3?
0.175.
0.175.
Yes.
Yes.
So
Okay.
you guys just typed that into the Z, and it
Yes.
gave you the answer. Okay.
Yeah.
All right. We can go on.
Okay. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after the tragic boat accident. The standard deviation of passengers' weight is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than the observed in the sample. Round your answer to 3 decimal places.
Okay.
Awesome. Okay.
So are we going with the mean or with the sample mean?
I went with the mean of 185,
That's what I would think too.
and then I took the 177.6 minus that 185.
Okay.
Divided by the 26.7 and the square root of 48. So it gave me a negative 1.920. And then we're looking for above and below. I have a 0.0549. Sorry.
Well, I can actually hear you now.
0.0.
Me too. So start over because I heard you the last 10 seconds.
Sorry.
You're good. Don't be sorry.
Okay, so I took the 177.6
Okay.
minus 185
Yeah.
and divided that by 26.7 and the square root of 48.
Yeah.
And I
You
got a
divided it by the
negative,
26.7.
yeah, that was the standard deviation.
Okay.
And the sample was 48.
So you're. So once I've got the 13.58, what am I doing? And then am I square rooting that?
Now,
Yeah.
can you see my
Yeah, I think she types all of the formula in, so I'm not sure we have the middle answer on that.
Yeah.
Nice
That's a
car,
nice
Leah.
car.
Sorry.
I know that's her dream car. Yeah,
Okay.
someday when I win the lottery.
Of
course I have to play it.
Right. In Idaho, right?
Yeah, true. There you go, Leah. We can see you if you want to show your calculator.
Okay. I don't know how big that is.
Right there's, that's good. 26.7.
Good.
By the way, the square root of 48.
Mm-hmm.
Is that good, Steve?
Yeah, hold it there for a second.
Okay. Yeah, you're doing well, Leah. No, it's not. It's good.
I know your hand's getting tired, but hold on. Okay, so after I get to the 26.7, I'm dividing the square root of 48.
Yes, that's the sample size.
Did you say yes?
Yeah.
Yes.
Okay.
Okay, so if we plug that into the applet, we get 0.055, right?
Mm-hmm.
All right, so everybody on 5?
Yep.
We get 0.55.
0.55.
0.055.
Right.
Okay.
Okay, so number 5. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, X. The distributions of a sample means, X. This cannot be determined from the information given. Wow. Okay. I am at a loss.
Yeah.
Okay, so
I
the
have no idea.
distribution of an individual observation.
Mm-hmm.
Smaller.
Which ones will have a smaller deviation? Or the distribution of a sample mean. Okay, let's see. What is a sample mean?
I have no idea.
Okay. Let me go on and research on this one if you guys want to move on to the next. Does that work? Okay.
All right. I can read this next one. Which of the following results implies that the spread in X decreases as the sample size increases? Be the normal distribution, the 68, 95, 99.7, the central limit theorem, or the law of large numbers. Would it be the law of large numbers?
That's my guess.
Because I think the law of large numbers, it says the more that you get, it
More even.
yeah, it goes more like towards the middle, correct?
I would say yes.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with the mean of 150.8 and a standard deviation of 8.8. Use this information to answer questions 7 through 10. The mean is 150.8. Deviation is 8.8. So Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? So would that be 160 subtract 150.8?
Yeah.
And then we divide that by 8.8. That one we divide it by? Because
Is the answer 0.1480?
I don't know. Did you do a square root of anything on the bottom part or just the 8.8? Sorry, I'm having a hard time hearing you again, Leah.
I got a 1.045.
1.045.
Did we put that into the app? Sorry, did we put that into the app?
So I did. And I got 0.1480. Or,
But I think it needs to be that 1.045,
Yeah.
because that's the z-score.
so the answer
we
is
just need the score.
1.045.
Yeah,
Yeah.
I think so.
So
do we agree that's 1.045?
yes, I do. I
Okay.
see it now.
And the probability is where we're gonna do the square root, right?
Mm-hmm.
But what's our sample size? Oh. Okay, let's see.
So now would that be
I think we put it in there,
in the applet?
yeah.
Let me.
So then it would be to the right. So it would be 0.148.
That's what I'm getting. Is that what you guys got?
That's what I got.
Okay.
Tell me what you did on that one, because I can't hear you guys.
Yeah, let me share the screen.
So, do you see my screen or did it go black again?
No, I see it.
Okay. So,
So the area is 1 point.
yeah, so it's the same number as you used before. Like that you put 1.045, but you just click on the very right part. And because that would be a score above.
Okay, so 1.480.
Yeah.
Okay.
0.148. Could
Yeah.
you hear me, Steve?
Yes.
0.14.
Okay.
What answer did you put in?
0.148.
Okay, good.
So a random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' scores?
So we would just add all those up and divide by 5.
Yes.
Well, I'm not having any luck on this. Which one are you guys on?
On number 9.
Number 9. Okay.
So I got 160.
That's messed up on my calculating.
So should we just take the high and the low?
I got
So do
160
we?
as well.
So 160, because if you punch that into the applet,
Well,
how
we
does
don't
it
need to
work?
punch that into the applet, do we?
So that is the answer, 160.
Well, I guess
But what is the Z-score?
Yeah, I don't think 160 is right.
160 divided by 5.
160 would be the mean.
Yeah,
So then
160 is your
take
mean.
that.
And then divide
Then we'd
by
have to
5.
take that mean and then find the z-score, correct? So we take. So would the z-score be? I don't know. So it'd be 160. Subtract 150.8. And then
But we don't know our
would that
speed.
be 8.8 with the square root of a 5 because there's 5
5 samples.
samples?
I think so.
Where did you get 8.8? Because I got 9.2.
Well, isn't 8.8 the number that we got at the very beginning with the standard deviation?
Okay.
Yeah,
I
we're
guess
still
we're
using
still
that.
going off of that. Gotcha.
Is it 2.337?
2.337?
Or 2.338 because you round up.
Okay.
If that information's right.
Yeah. I see. I'd go with that.
Are we going with the 2.338?
Yeah.
So if we put that into our graph
Mhm.
and then just go to the right side of it, then we get a probability of 0.0097. Another 10.
You got
Yeah.
0.0097?
For number
We'd
10.
have to round that up so that just be 0.01. Right.
It says go to 4 decimal
Would
places.
be 001.
4.
No, 0.
It says 4
It
places.
does say 4, but it's probably because of what it is.
Oh, okay.
So 0097.
If we're doing this right.
You guys are still on 9, right?
On mine I got
That was-
2.338.
How did you get that, Leah?
I just want to calculate it.
Okay, let me get to it. Where'd you get the 8.8 from?
From our last question.
Oh, okay. So that's the problem with jumping in the middle of things, huh?
Up on
What did you
number
put for
7.
9 again?
She says 2.238.
Oh, I got 2.338.
Yeah, I thought it was 2.33.
Oh, okay, yeah. I'm sorry.
Okay.
I can't even blame that on dyslexia.
Can I put my arm down now?
Yes. Thank you, Leah.
So if we put the 2.338 in the box trace,
Okay.
and to the right of that is the probability of, I think, the 5 randomly selected students.
Should be on the right-hand side of the normal probability applet. So you're getting 0.0097.
Yeah.
You want me to read the next one?
Sure.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of N81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable var x, which represents the sample mean of the 81 students who are selected?
Would it be normal because
I'd
it's a
say-
high number?
Yeah, I'd say normal because it's a higher number the sample is.
Yeah, I would agree with that.
Alright, what is the mean of the distribution of the sample means? Sampling distribution for all possible samples of size 81 that could be drawn from the parent population. Round your answer to one decimal place. For example, if the answer is 1.2873, then you would enter 1.3 in the answer box.
Is it 3.5?
Couldn't hear you.
I think it's 3.5,
3.5.
just because it says in the.
Yeah, it says it's already given us. It's 3.5. Suppose the mean of the GPA of BYU Idaho students is 3.5.
Yep. I think you guys are right.
So the answer is 3.5.
Mm-hmm.
Oh, okay. I get it after you read that again.
Standard deviation is 0.7.
Yeah, I think it's 0.7.
Which one are you on now?
So we need to go out 3 decimal places, 0.700.
I don't think. I think 0.7 would be.
Yeah, you'd hope so, huh? Okay, so what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Round your answer to 3 decimal places.
Okay.
Drop it down. Oh, yeah, that. So 2.571. So we need to plug that into the 2.571. Oops.
And we need to put that in the applet, correct?
Yeah. Now, okay, so which side is this going to be on? Is this going to be just the left, far left side, or the middle and the left?
So
I'd
let's
say the left.
Okay, yeah. So if you put it in there like that, it's 0.0051.
Yep. Great that too. So it says 3, so it would just be 0.005.
Yep.
0.005.
Yeah, sorry, I shouldn't do that.
Oh, make sure I got this right. 12 is 3.5, 13 is 0.7, 14 is 0.005.
Yeah.
Yes.
Put zeros after 13 to 0.700.
Just to be safe.
Did you hear me, Trace?
Yeah, I think so. Did you hear that, Stephen?
I did not.
We're not chancing it. We're putting 0.700 on 13. Just
Okay.
going the 3 places. It may be, I don't know,
Okay.
Better off.
wrong, but yeah, I mean, it's at least it's there. Okay, 15. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? So we're just stay on that same applet, right?
Yep.
And click the right 2.
Yeah, so the middle and the right, correct?
Yeah.
So it's
0.9949.
0.9949, so it would be 0.999.
So I got
995.
0.995.
Yes.
Yes. Oh, yeah, sorry. My brain is gone.
Are we going to 4 decimal or 5? Or 3 or 4?
It's
3.
3.
4?
So 0.995.
Okay. Then we need to go back.
Wait a
Yeah,
minute.
we need to go back to those. I want to kind of look at this number 15 again because I'm really not following this one for sure. If our
So I got,
mean,
hold on, I got 0.999. So where did you get a 5?
Because you rounded up.
rounded up, I had a 0.9949, and so I rounded the 4 up to a 5.
Do you
Hold
see
on.
on my screen, Steven? I screen shared. See if yours looks like that.
Okay.
Yeah,
Let me go
okay,
back to
so
mine.
if our mean is right here in the middle, right where that 0 is,
Uh-huh.
and that's 3.5, right? Oh, okay, yeah, I'm sorry.
It's okay.
My head's just not in it, because 3.3 would be clear over there by the left-hand red line. Yeah, I'm just answering my own questions. I'm extremely tired.
It's okay.
Yes,
You take the 1 minus the 0.005.
you get your answer.
That will also give you the answer.
Yeah, that's true. Okay, so while I was gone, number 5, I bailed on it. I really can't find where they talked about individual observations.
Yeah, I looked in the reading and stuff for it too, and I couldn't figure that out as well.
Right? Yes. It talked about the distribution of a sample mean.
Mhm.
I would go with the sample mean of X bar.
Yeah, I mean I would say that that's the best guess that I could come up with on that.
Mhm.
On, would it be A?
On
I
number
can't
5,
hear Leah.
the distribution of the sample mean X bar.
Okay.
So B. Okay.
Yeah. Okay, so number 6, 7, and 8, I do not have.
Okay.
Law
First 6.
of numbers.
Yep.
First 6
7.
is law of large numbers.
Yeah.
Yes.
Okay.
7, we had 1.045.
Okay.
And then 8, we had 0.148.
Okay. All right. I'm going to submit. I will let you know how it comes out.
Okay.
Hey.
Okay. Number 13
Yeah.
is inaccurate.
Huh.
Okay. And number 13, we just need to break that down further. So if we have, let me put it in spreadsheet here.
So do we not need to put the 2 decimals at the end?
No, we were okay doing that. You need to put those in there, but the .700 is inaccurate because we're supposed to break that down. So we need to take the 0.7 and divide it by the square root of 81.
Yep.
I knew that. And so it should be
1.
0.0778. So it's going to be 0.078. Okay, so you guys got that in there?
Mhm.
All right.
All right.
Yeah, I knew better than that.
So are we all good for the night then?
We are all done.
All right. We'll
Oh my
see you
goodness.
guys on Tuesday.
All
Thank
right.
you guys.
Take care, guys. Have a good weekend.
You too. We'll see ya.
See ya.